In this lesson, we're going to take a look at how to calculate the empirical formula from analytical data. We call the empirical formula the simplest whole number ratio of atoms or ions that make up a chemical. There's a simple rhyme that sometimes works. It's easier to remember. The rhyme sounds like percent to mass, mass to mole, divide by small, multiply to a whole. Step 1 of the rhyme simply means to take the percentages and convert them to mass amounts by changing the label to grams. Therefore, 58.87 grams of sodium, likewise 41.13 grams of sulfur. The second part of the rhyme, mass to mole, means to convert these masses into mole amounts. In order to do this, we simply need the molar mass for the elements. This comes from the periodic table. 1 mole of sodium atoms would have a mass of 22.99 grams, and 1 mole of sulfur atoms a mass of 32.07 grams. We now have two mole amounts, 2.56 moles of sodium, 1.28 moles of sulfur. The mass is converted to moles simply by dividing by the molar mass of each element. The next part of the rhyme, divide by small, means to divide by the smallest of the two mole amounts. The reasoning for this is to try to create a whole number. Therefore, we're guaranteed that one of these whole numbers will always be 1. Since 1.28 is the smallest, we will divide each of them by 1.28. If we arrive at two whole numbers, or something extremely close to a whole number, we can accept these whole numbers and write a formula from them. In this case, we can see we get exactly 2 and 1 mole. By putting this back together in formula form, we end up with what we know as the empirical formula, Na2S. Generally, this number won't always be close to a whole number. Therefore, we may need to implement this last part of the rhyme, multiply to a whole, which means we would multiply each of these values, 2 or 1, by some other value until we created a whole number. Let's see if we can take a look at an example where we find this circumstance. Again, following the rhyme, we see that we have 89.14% gold. We'll simply take this percent and change it to a mass amount. Likewise, we'll do the same thing for oxygen. Next, we implement the mass to mole step. In this case, we'll have to look up the molar masses for the elements gold and oxygen. This will create two mole amounts, a mole amount for gold and a mole amount for oxygen. Once we have the two mole amounts, we then divide by the smallest of those. In this case, 0.453. We can see when we divided, we did not get two whole numbers or anything very close to two whole numbers. We got the values 1 and 1.5. Generally, you'd have to be within 1/10 of the value of the next whole number in order to accept it as a whole number. Since 1.5 is not, we're going to have to multiply to a whole in this particular case. So we're going to look for a number that we would multiply 1.5 by that would eliminate the half value. Typically 2 works, especially when there's a half amount. Therefore, we would end up with 2 and 3 as our mole amounts. If we put these back together to make our formula, we would see we need 2 gold and we need 3 oxygen. Our empirical formula would therefore be AU2O3. This final step of multiplying is not always necessary because sometimes the values that you receive from the division excuse me, are already in whole number form or extremely close to whole number form. Again, you will be looking to see if that value in mole amount is within 1/10 of a whole number. In this case it was not, and we had to multiply to find a whole value then.